something here very important. This is the data about humans versus machine chess. Green says AZ wins and that is AZ draws. Okay? That's alpha 0. So whenever the machine plays first, which is in chess, when I say domain knowledge, this is what? You must know how the chess is played, what are the rules of the chess, etc. etc. So when the machine plays white first, it will win 29% of the time, and the remaining 71% it will not lose. Draw. So whenever machine plays second, that is human makes the first move, there is a very small percentage, 2% chance of human winning, and approximately 97% draw. Very rare that the machine will win after human plays first, which is less than 1%. Which means AI solutions are of the following type. Don't lose. It's not designed to win. It's all designed not to lose. Being with humans, what happens? Humans by nature are inconsistent. Why they are inconsistent? Because they are humans. They have problems of fatigue, they have problems of all that. That's why today, I'll tell you why AI is becoming popular. AI is becoming popular because a lot of people in many companies want to make more profit without giving salary and without shift. 24 hours machine will work without salary. So if you have 3 employees remote in 3 shifts, 24 hours, 3 shifts, my machine can do that job better. It will not take salary. There is no coffee break, tea break. There is no issue of transport. This is what is a small number of people in the world want to make more money, and that's the main social reason that AI is being pushed. Be very clear. AI will take away jobs, but AI will not take away jobs. You will get replaced by people who know AI better. That is what is going to happen. It will still be replaced by people, but those who know AI. So it's very unfortunate that another 4 or 5 years, your first level entry, first question is after your name, second question is do you know AI? You don't know AI. If you know AI, we will continue the interview, otherwise get out. This is what is going to happen. Same with another game called Shogi, we will not get into. Look at this Go game. The Go game is interesting that whenever the machine plays first, it is 70% win and the other 30% it loses. There in Go game there is no draw, there is win or loss. So basically AI strategies are, even today AI is trying to compete with humans in intelligence. But that will stop soon. It has already stopped at research level. One company machine will compete with another company's machine. That is what is going to happen. That's already happening now. And that will become more prominent. Right now it is the first stage of AI where it is comparing itself with humans.
Sir, this data is against human or against stockfish? Because it's written alpha 0 versus stockfish.
Yeah, alpha 0 versus starfish. Here, stockfish here. Yeah.
So this winning goes in data.
All that with also includes humans. Okay. Now what is happening is because of that, this has happened. You now have very interesting companies. What do? Their business is to produce very powerful search engines in exceedingly specific domain. This is a search engine only to play chess. And today it can think of 1 million moves, whereas human grandmaster can think of hundreds to thousand moves ahead. This can think of million and then move. There is no way you can compete. And not only that, because of this, you now have companies which make search engines for 100 different domains. There are search engines for music, there are search engines for movie, there are search engines for pharmaceutical composition now. So today, you can buy a search engine which is trained on one specific domain. Let's say pharma. It can search and give you the best combination of medicine at the best price, which location, all that. That is what is happening. All your so-called recommender systems that are there have this. You have this when you buy in Amazon or whatever you buy, the person who bought this book also bought this, another 5 will come. After that you can search, same thing, buying car, buying clothes, everything is now like this. Every big company has a search engine which will look at your search and give you multiple other options. It is already doing for colleges also now. Colleges, courses. So one of the things that happened was that it started losing to the human being, the Go search engine, which is Go machine. And really 2015 is a critical point in modern machine learning, where the software or whatever you call, I call it a machine. Machine is a combination of data, algorithms, hardware and system software which makes it run. So the ML machine was able to defeat the world champion consistently. How it did is interesting. It never played the human expert. What they did was this memory-based thing of trying to defeat a human by playing with a human and learning, which happened in chess, failed in Go. How to defeat this? So this is where companies like Google come into the picture. Google is not a great company. It is a company which is exactly opposite of this college in everything. That is why it is great. No rules. Absolutely no rules. No dress code, no timetable, no nothing. Except you have to do your work the way you want to do. You want to work from home, you want to do in holiday, whatever, but deliver. So what Google employees did was, very interestingly, they took an elementary machine, well, it had enough RAM and speed, all that. They put the rules of the Go game to the machine, made a copy of that. It's easy to copy in software. So you had 2 copies of the Go game, and in one copy of the Go game, they altered certain what is today called as parameters or hyperparameters. Those are numbers. So solution means a set of numbers. Machine learning means solution means a set of numbers which you call hyperparameters or other things. Those numbers were changed. So you had 2 copies of the Go game with all the rules intact with different numbers, or indirectly saying 2 different human beings are modeled. They made the 2 copies of the software play with each other on this one machine. They played for 4 hours. Then they stopped the machine, removed 1 copy of the program, asked the world champion to come, and he lost. So one machine taught the other machine how to defeat a human in 4 hours. This is really the critical part of, this is first instant of machine learning, where a machine actually taught. So far it was humans teaching the machine to play. Here it is a machine which taught another machine how to defeat it, and it is now happening. Today you have killer drones programmed to kill people. All it has on the memory is 1 or 2 or 3 or different versions of the image of the person to be killed. It will match everybody on the road, and whichever matches, this is really what happens. So modern AI machine learning has a very, very wicked part of it. Not a very benign thing, it's a very malignant thing that has happened. But you make more money on that, that's the reason. Okay? So this is it. machine teaching another machine. So this is the first stage of AI which got closed. Replicate and do better than what humans can in limited or specific intelligent tasks like checkers, chess, quiz, go game. Mostly problems of games and contests. There were no great solutions available other than some credit card issue, rather than critical problems of human needs, but yielded critical learning paradigm and also belief of possibilities. People started believing that yeah, something can be done. So the first stage of AI machine learning closed with doing games and games of play better than humans. So where it's actually heading is this. It's another industrial revolution. This is the fourth one, what one calls Industry 4.0 in mechanical terms. So basically you're looking at autonomous decision making of cyber physical systems connected through net using IoT. Whenever it is autonomous, it means local intelligence is there. That's where it is going. Okay? Will it stop here? No. The fifth one is already emerging. Okay. So what allows interesting problems to be solved? Interesting problems are perception problems. They are not data problems. Somebody composes music. Music is all about raga and rhythm and tara, whatever. If there are words, it has meaning. And many interesting music has very bad grammar. When it is interesting, it's interesting if you break the grammar rules. That's why poetry has very poor grammar. That's why it's very interesting. Prose is dull because it has very good grammar. Emails are dullest because it lacks both grammar and this, right? So these are perception tasks. I am seeing all of you. I am also seeing the chairs. I am seeing the laptop. I am seeing so many objects. How do I recognize who is who, what is what? How do I distinguish a male from female? How do I do that? If you give me a task, I can easily classify, which is what afternoon task will be. Classify all of you correctly, one group as males, another group as females, I can do it. 100% correct, I can do it. I'm just seeing many of you for the first time in my life, I can still do the job correctly. That is perception task. I am not trained. I have evolved like this. It's also part of the training, but I have evolved like this. This will be difficult in China. In China, it will be very difficult to distinguish boys from girls. First thing, they have no eyebrows, they have very similar face, no facial hair, no mustache, nothing. They are same size. Very difficult. 50% error guaranteed. So, what these perception tasks are? Things that, if I look at this stapler, I want to recognize that object. The stapler is not anything like, or this water bottle. I want to pick the water bottle. I can't pick like this. I can't pick like this. It will fall off. I can't pick like this because it will not drip. I must have exactly this boundary. Now to drink water, I need the boundary of the cap. But to drink the water, I can't work with the boundary. I have to work with the inner content. So this is what brain does. Whenever you look at an object, brain represents different parts of the object in different resolutions and different parts of the brain. Data doesn't do. So data level processing will tell you whether it's a bottle or not. Beyond that, it will not tell you. This will tell you what is the cap, what is the shape, what is the texture, what is inside, etc. etc. So I need data, different aspects of the data to be captured. That is where machine learning works. That's why machine learning uses a lot of data, because it doesn't use just data alone, it uses multiple avatars of the data. For example, you can have a data about an object as though seen through a microscope, as though seen through a telescope. From microscope to telescope, 100 different avatars of that can be recorded. That's what deep learning does. Humans are better at perception tasks than number crunching. Machines are better at number crunching than perception tasks. Now the machine learning problem is, I am good at number crunching, but I want to do perception tasks. That's why machine learning is so glamorous, because using a very stupid computer, I can do intelligent tasks. Computer is basically a stupid entity, it's a slave. You ask it to do that, it will do. You must know how to ask it to do, and that is the language of programming. So, getting that is the trick. And see why it is difficult. I see the motorbike, this exhaust portion, but computer sees it as an array of numbers. From an array of numbers, it must be able to tell that it is a motorcycle exhaust. So if I can do it for motorcycle exhaust, I am done. I just have to make multiple copies of this of different parts and then join them together. If I can do one task very well, one stupid task very well, one stupid task intelligently well, computer can be made to do 100 times that. The trick is in converting numbers to ideas and perceptions. That's the trick, that's the difficulty. It does now for image sequence, audio, text. Now you have ChatGPT which gives you summary of a paper, summary of a thesis, everything. This is what it does. Okay? So most real life perception problems are pattern problems. I am recognizing a pattern. For example, I want to sit here. I must know that this is the interior. I cannot come and sit from this side. So once I come and say, I really don't plan whether I'm exactly sitting with same gap on left and right, all that. I must be very clear where I'm going to sit. So that's really what I'm looking at patterns. I'm not looking at the data about the chair. I'm looking at the pattern of the chair and saying which portion is to be used for sitting. Suppose I want to sit on the table. Table is not meant to be used for sitting, but we do that as teachers occasionally, we sit on the table also. So I must know which portion to sit. Now here I can sit all round. Unlike chair I can only sit here, I can't sit all round. So all these are patterns. So machine learning basically looks at patterns in data and processes the patterns. It doesn't process data. It cannot process data. Data today is so voluminous, there is no way you can ever get result trying to work out all the data. You must somehow take the data. That's why visualization is a very important part of machine learning. Seeing is believing. The picture is worth 1,000 words. So you can actually get a better idea of what the data is all about. Okay. This is what. So where are your problems today? Plenty of problems. Today things have changed. Languages change. Problem means not a problem. Problem means data. I want data about the problem. I don't explain the problem. I provide data about the problem. 1,000 jet engines have failed like this. Where is the data? Yes, 1,000 jet engine data is available. I know. Then I check patterns for that and then identify a pattern which tells its failure and then make sure that it doesn't happen, or when it happens, what action to take. That's exactly how all this machine learning. So, I want data about the problem. When you have data about the problem, data is too voluminous. Terabyte data is a very small data today. All your Google, Amazon, Facebook doesn't work on terabytes. It has already crossed petabytes. What I want is, from that data, I look for features. So I have data about so many chairs. I look at a feature which is like a bowl here to sit. Here I look at an overhang to sit. When I go there, I want to know whether I can push the door that side or pull it. That's why door handles are given. Why are door handles given? You need a bolt to lock. You don't need a door handle. Why is door handle given? It tells you where to push or at least where to hold and pull, whatever. This is really what it is. So I basically want features about the door, features about any object. Now two things. If you have a feature and it has a label, you generically say data has label. What is label? If feature Kannada word is Lakshana. So you identify something with the feature, that is called label. For example, most doctors will go, and when you go, even if you complain about fever, they will first to pull the eye down and see. Why do they do that? Good doctors do that. What do bad doctors do? Send you to the pathology lab. Today, our doctors are as bad as our engineers. All professions. All professions. So they pull the eye, first thing they do is check whether the eye is yellow or not. Because in tropical climate, particularly for children, jaundice is very common. Yellow eye means jaundice, no other. That is a confirmed label for feature. What doctors do is basically early part of machine learning. They ask you to cough, they put a stethoscope, some of them take a small hammer and hit here to check your reflexes, right? Then they ask you questions, right? That's a good doctor. Bad doctor will take a printout and say, get all these checked and come, I will talk to you later. Like what do you know about machine learning? I know Python. What else do you know about machine learning? I know Python. Not one college, including IIT, tells this. What do you teach in machine learning? Not one college has said, I teach these domains. They say we teach Python. What else you teach? We teach Java also. What else you teach? Nothing else. This is enough. Yeah. So, once you have a label, you can classify it. Classification means yellow eye means jaundice. No yellow eye, you may be sick. It is only non-jaundice. Jaundice or not jaundice. One line, everything on the left side is jaundice, everything on the right side is not jaundice. It may be something else, but it is not jaundice. This is what a classifier model does. I can divide it into two classes. From two classes, I can divide it into 200 if I want, right? Once I can do for 2, I can do it for 200. That's how your tree search, tree-based classification comes. I can do. So a computer is very good to do repeated tasks. You teach it correctly to do for 2 classes and it will do for 200. Suppose I don't get labels. I get data, which is always available, but I don't get labels. What do I do? That part is on the left side, which is called a clustering model. We have a nice phrase in English, birds of the same feather flock together, which is nothing but, technically that word is called cluster. Here also I am very sure many of you have automatically clustered yourself. Your colleagues, you sit together, right? This was a chance to sit with somebody whom you never knew in your life. You don't want to do that, yeah? So clustering is natural. You cluster. From the cluster you can extract features if you want. ಇವತ್ತಿಗೆ ನೋಡ್ತಿರಲ್ಲ ಯಾವುದೋ ಹಕ್ಕಿ we call it 7 sisters. 7-8 ಹಕ್ಕಿ ಒಟ್ಟಿಗೆ ಹಾರೋಗುತ್ತೆ, ಒಟ್ಟಿಗೆ ಕೂತ್ಕೊಳ್ಳುತ್ತೆ, ಒಂಥರ ಗೀಜ್ಗಲ್ ವೆರೈಟಿ ಹಾರೋದು. So that's clustering. Animals cluster, humans also cluster. So from clustering you can take label for that and work it out. Okay. So basically two major types of problem solving. Classification based if labels are known, clustering based if labels are not known. In between is also known. Partial labeling is there, occlusion, so many other. We will not get into. So what is important is role of features, not role of data. Can I get features directly? Then I will solve one problem easier. I will take features directly. Features have to be extracted. That is why you go to an experienced doctor. Who is an experienced doctor? Experienced doctor means he has already killed 100 patients in his life. See, it is on failure that you build correct knowledge. You don't build on success. It's on failure you build correct knowledge. Good lawyer means that he has already failed in 100 cases. Hopefully, that failure will make sure your case is successful. Experience is not easy. Expertise is not at all easy to give. You acquire, you learn, you imbibe, they get mentored, they get, they go sit in, that's why senior doctors in the hospital on rounds, they take all the junior doctors with them. And a good senior doctor will actually teach them with every patient. Go to every bed and say this, look at the data and then ask them what they think, then he will give the correct interpretation. That is not there. See, the problem with expertise is, if you give expertise to others, they will become your competitors. That's why don't give expertise. Severe cardiac problem irutte. Ninge flu tara helkodಕೊಂಡು ಬರ್ತಾರೆ. That's very important. So what you get is not features. What you get is data. You have to extract features out of that. That is really the intelligence. That's why everybody can sing. Everybody can sing. Only thing, there are most people, when they sing, nobody wants to listen to them. Right? Features of their singing is very poor. So you have all, from supervised all the way to unsupervised, semi-supervised, reinforcement, deep learning, all varieties. So now theories of learning itself is there. In what all ways people learn? 100 ways people learn. But what has suddenly become surprising? Did you talk to Hari Sandesh about Kumarila Bhatta? Kumarila Bhatta was a philosopher just before Shankaracharya. Okay. So one person who actually was in a Buddhist school, learned Buddhist philosophy and used Buddhist philosophy to counter them. And he commits suicide. He says, I have cheated my teacher. Just before he meets Shankaracharya, he immolates himself and says, I have cheated my teacher to defeat him. That karma I cannot endure, so he commits suicide, he burns himself. Okay? But today, from last 2 years back, from 2020, every year there is an annual Kumarilla Bhatta's conference either in America or Canada, because what philosophy he did and what he did to counter Buddhism using Buddhism tenets is now used in advanced version of large learning models. What is the technique to learn from something and beat it? That's the conference. Only Americans and Canadians are sitting there. I don't even find Indian names in that. Okay? So that's really what it is. Plenty of work on ways to learn. These are standard ways. Okay? So this is how typically it does. You use data. How do you get data? Data from sensors. So AI machine learning today is working because you have obscene number of sensors, very cheap. You have 40 different types of sensors. ಕೂತಿದ್ದಕ್ಕೆ ನಿಂತಿದ್ದಕ್ಕೆಲ್ಲ ಡಾಟಾ ತೆಗಿಬೋದು, ಹಂಗಾಗಿದೆ ಈಗ. So what do you do with this data? Well, you do machine learning. If you didn't have this data, nobody would have given you machine learning. Data is available because of sensors. Sensors gets all kinds of data including noise, so you pre-process, you extract the feature and you train a classifier. Training the classifier itself is an interesting task. You do that. And then you use the trained classifier for new data of similar kind. If you are recognizing faces, you have to capture new face data and see what it is. Same process. Take the features from that, put it into the classifier, and it will declare male or female, whatever it is, right? You spend a lot of time training. And today, I want continuous data. Continuous data is available from sensors. But taking that, feeding it into a machine or algorithm where it takes data in real time, here is the process where you need the IoT. So that's why today IoT is the silent backbone of machine learning, other than certain legacy tasks and very big data tasks which Google, Amazon do. But for most Janta applications, it's all IoT driven. The other thing is there is no one way to learn. Therefore, there is no one way to actually group data. So when you have labels, you can do supervised. In supervised model, you can either do classification or regression models. And when it's unsupervised, you will do clustering. And for each of them, there are half a dozen algorithms. This is one other issue with machine learning, meaning you need to know many ways to solve a problem, because there is really no one way to solve the problem perfect. Definitely not single way to solve a human problem perfect. Many ways to solve. In fact, so much so that we take the data, use a classification method, sometimes we use different classification methods, take the results from each of them, fuse it. It gives even better. It's like a cricket all-rounder who can win the game either through batting or through bowling. That's really what it is. Even worse, can I take the same data through different sensors? Yes. We do sensor fusion. For example, typically faces you take with camera, you also take face with infrared camera. So you take data from infrared camera, regular camera to fuse it. It's happened. That's how you do night vision surveillance. Night vision surveillance is done by superimposing daylight camera with infrared camera data. This is really what it is. So machine learning means you have data, some expert to extract the feature, put it under a classifier. Deep learning does the following. It will simply eliminate the expert. It will take huge amount of data. This is only color is blue, but the data here equivalent of this is approximately 100 times more. And the network is dense and multi-layer. You will get an answer. Now suppose here the answer is wrong. You can go ask this fellow why it is wrong. You can change the doctor. That's why you take multiple opinions, right? Second opinion you take. Many times you take second opinion even with a lawyer, right? And I'm sure when people join colleges, they would have explored half a dozen colleges before selecting. Here the problem is when something goes wrong, you don't know why it went wrong and you also don't know whom to ask. The power and beauty of this, it is also very obscene, very vulgar. What they are saying is, I have collected so much data in the world that all the possibilities that can happen, one of them is already there in that. I have used it to train, so you get very good result. Two things happen. Anybody who doesn't follow Kannada?
All of this.
ಯಾರೋ ಅನ್ಫಾರ್ಚುನೇಟ್ಲಿ ಹಾಸ್ಪಿಟ್ಲಿಗೆ ಸೇರಿಸಿರ್ತಾರೆ, ಬಂದಮೇಲೆ ಮನೆಗೆ ಡಿಸ್ಚಾರ್ಜ್ ಆಗಿ ಬಂದಮೇಲೆ ನೀವು ಹೋಗಿ ಸ್ವೀಟ್ ಎಲ್ಲ ತೊಗೊಂಡೋಗಿ ಡಾಕ್ಟರ್ಸ್ಗೆ ನರ್ಸಸ್ಗೆಲ್ಲ ಕೊಡ್ತೀರಾ? ಇಲ್ಲ, ಕೊಡಲ್ಲ. ಸೊ ವೆನ್ ಸಮಥಿಂಗ್ ಗೋಸ್ ರೈಟ್ ಯು ಡೋಂಟ್ ಬಾದರ್. ಡೀಪ್ ಲರ್ನಿಂಗ್ ಇಸ್ ವೆನ್ ಸಮಥಿಂಗ್ ಗೋಸ್ ರೈಟ್ ನೋಬಡಿ ಬಾದರ್ಸ್. When you make lot of money in stock market, that fellow will say how much money to give you and cut you off with other things. Only when something goes wrong. I keep hearing news. Kallu hodidru hospital ge ella patients maneyavar bandru antu. So only when something goes wrong you question. When something goes right, nobody questions. So this is what deep learning is. Deep learning simply says, I have looked at 10 billion data. 10 billion is very small. 1 trillion data possibilities. I have analyzed. You can be only one of that 1 trillion. So it is. So whatever comes out, people take it and they get away. This advantage of this is eliminated. Being an expert is always very difficult. So this is how it is. Take lot of data, train the algorithm. When you say trained ML algorithm, that is what a solution is. Nobody talks of what the architecture of the machine is, whether it has a 5 GPU or 10 GPU, all that they will not. Basically it says the algorithm has been trained very well, and when new data comes, it will predict the output correctly, you use it. But what happens when the answer is wrong is interesting. When the answer is wrong, it means this data is not the one you have used for training. It doesn't belong to that set. It is a new data of a similar kind which will only improve your algorithm. One only good thing about machine learning is it loves failure. It builds itself on improving with failures, and that's why it does. Don't think that the models that they give you are new. They have tested it on trillion data points before they release the model, whether it's Google or Amazon or anybody. So you must put a data which is not in 1 trillion. If you put that data, two things will happen. You will get wrong result. That Amazon or Google will pay $1 million for you to get that data. You may die, but your family will get $1 million. Rare data. So, because you can put more data, people use deep learning. Because other learning saturate. ನಮಗೆ ಹಿಂಗಾಗುತ್ತೆ, ಪರೀಕ್ಷೆ ನಾಳೆ ನನಗೆ ಎಷ್ಟು ಅಂತ ಓದ್ತೀರಾ? ಅಯ್ಯೋ ಸಾಕು, ಇದಕ್ಕೆ ಎಷ್ಟು ಮಾರ್ಕ್ಸ್ ಬರುತ್ತೋ ಸಾಕು. Even worse are people who, and do you notice children have lost the speed and the endurance of writing now? For some program like this, I was there in MSRIT 2 years back. HOD of mathematics said the brightest student in the college, but he has a peculiar problem. 3 hours exam, he will write for 2 hours. He will say, ಅಷ್ಟೇ ಆಗೋದು ನನ್ನ ಕೈ ನೋವು ಬರುತ್ತೆ, ಅದಕ್ಕೆ ಎಷ್ಟು ಮಾರ್ಕ್ಸ್ ಬರುತ್ತೋ ಬರಲಿ. So that's really what it is. All other algorithms tend to saturate. Even if you put more data, in fact, if you put more data, there is a chance that it may overfit and put you into trouble. But deep learning is not like that. So there is a tendency to say, getting data is cheaper now, it's well established. So let me use deep learning because its performance will improve as I put more and more. And it's probably better than other learning schemes. So that's why the deep learning is done with a neural net. Neural net sessions are there. Martara? Neural net. So this is a single layer neural net which is basically a line in, suppose you had only 2 neural nets, two perceptrons, I would have got ax plus b equal to c. So it is a line in x and y coordinate. This will be a line in n-dimensional coordinate. This will be multiple lines in n-dimensional coordinate, and that's how the deep learning is. So for example here, simple mechanism to train to classify dog and cat. This is a 3-layer neural network which can classify dog and cat correctly, provided you train it well with 1,000,000 dogs and 1,000,000 cats. Not only train with 1,000,000 dogs and cat samples, but when you are training with cat, you must say this is cat, not a dog. When you train with dog, you must say this is a dog, not a cat. Computers are very dumb. Don't think they are intelligent. Not yet. Not yet. And deep learning does this. Today, very powerful deep learning machines. You have convolution neural net. This is your CNN architecture for just recognizing alphabet 2. Another problem with machine learning, with standard college and other architecture, people think everything can be put as machine learning. You must know which problem deserves machine learning solution, which does not. Your PhD does not deserve machine learning answers. Your journal articles don't deserve machine learning articles. Why should you use machine learning for generating your PhD thesis and journal papers? You can't think. Today it's very bad. A large number of pending papers in Nature because the editor feels somewhere the authors have cheated. And what is the percentage of cheating now? It's about 99. What is the percentage of cheating in VTU? 99.9999. So it's just to recognize character too. You have a very powerful architecture, but this powerful architecture can be used for many things. ನೀವು ಇಲ್ಲಿಂದ ಮನೆಗೆ ಹೋಗಬೇಕು, ನಿಮಗೆ ಮರ್ಸಿಡೀಸ್ ಬೆನ್ಸೇ ಬೇಕಾ? ಆಟೋ ರಿಕ್ಷಾನು ಸಾಕು ಅಲ್ವಾ? ಅದು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ವಿಚ್ ಪ್ರಾಬ್ಲಮ್ ರಿಯಲಿ ಮೆರಿಟ್ಸ್ ಎ ಮೆಷಿನ್ ಲರ್ನಿಂಗ್ ಸೊಲ್ಯೂಷನ್, ವಿಚ್ ಡಸ್ ನಾಟ್. ಎಲ್ಲದಕ್ಕೂ ಮೆಷಿನ್ ಇಸ್ ವಾಟ್ ಅ ಪ್ರಾಬ್ಲಮ್. ಮೆಷಿನ್ ಲರ್ನಿಂಗ್ AI ಮೆಷಿನ್ ಲರ್ನಿಂಗ್ B ಕೊಟ್ಟರೆ ಅವ್ನು ಇಡ್ಲಿ ತಿನ್ನಕ್ಕೂ ಮೆಷಿನ್ ಲರ್ನಿಂಗ್ ಅಂತಾನೆ. The first thing is needed is when to use, when not to use. Plenty of different architectures, various autoencoder, generative adversarial network, reinforcement learning, recurrent, hybrid approaches, everything has come. And you use for different domains. Okay. This is other thing. You must know many ways to handle people. Those are successful managers. One of the most successful managers in India was Abdul Kalam. But he was also one of the dumbest scientists on earth. He didn't know anything. Very successful because he could handle hundreds of variety of people very correctly. This is it. You must know a dozen ways to solve a problem. And a good problem will not get solved with one technique. It's not like Laplace inverse. There is only one technique that you do that. You do partial fraction expansion, take it up. No. Because you need to know many ways to solve the problem, students don't want to learn. Because they have learned one way to solve the problem, and that problem can be used for every domain. I know 8051. I know 8051 programming, or I know C programming. I don't know anything else, I know C programming. How do you solve the problem? You don't, I will not solve the problem. You solve the problem, tell me where to code, I will code. That is problem solving. Can you change? This is really challenging. And it's going. Today's more and more machine learning is going towards what is a crude brain. First generation was rule based, second one was statistical pattern recognition, third stage is now the brain model. And why it succeeds is this, plenty of stuff. Why ML succeeds is powerful computation, lot of training data, model captures the phenomena, most important, data and domain and the model for that links, reinforce, you can reinforce it and develop validity. So very important for using it is domain knowledge, that's necessary. And healthcare, you can see here plenty of interesting things going on. These are things which are already happened, some are being deployed, some are implementation challenges, etc. This is a case of how machine learning is used for healthcare. This is the feature. The feature vector contains age, gender, so many diabetes, hypertension, all this hemodialysis data. So there is one such data about patients is used for training, and it will produce 3 classes. What are the 3 classes output? The 3 classes output, one is whether the patient is surviving, whether based on that the patient is headed for a fatal arrhythmia. The third one is heart failure and death. And it is trained on thousands of patients like this, both using ECG and other things. You can either do a supervised learning model where you have very good ECG data with labels, arterial fibrillation, non-AF and so on. Or you can have convert waveform data into point data using standard QRS complex thing, and you can do clustering. So both supervised and unsupervised combinations of that. And what is interesting is these are individual patient data supplied to a doctor. What we know is the following. If the doctor gets critical patient's data 8 hours in advance, that is not just the instantaneous data, but trend of data for 8 hours, particularly the last 4, 80% of the patients who otherwise die can be saved. So I want to stream that data into, today it's possible. Doctors have a smart device which they can easily look at any. So what you need is to collect this data from the patient. That's why bedside monitors are dominating now. I want to collect the patient data right there and put it into a server or stream it. And how do I do it? It's like this. This is how all ICUs look now. They are collecting hundreds of data from the patient continuously. Other success. For example, here, one patient in Bangalore was saved. He got a message on his smartphone saying, "You are about to die, go get yourself admitted." So he got admitted, he was saved. He was saved because his real-time streaming data was being processed in Pennsylvania where he had insurance. He had come on a vacation to India and COVID happened, so he had to stay back. It happened in Anandpur. He's a Anurag Devices employee in Bangalore. So he has a smartphone and a wearable device, basically a IoT sensor, that the doctor saw in the morning and told you, go and get yourself admitted, tell them you are heading for a heart attack, ask them to get prepared for it. They will say, this really works. So anticipatory healthcare is already there, it's part of insurance. It will happen in a very big way in India in the next 5 years. At least half the middle class will go for it. And 2 major health insurance companies in the world have compulsory rule that you have to wear a band that they give which monitors data continuously, otherwise insurance is invalid. See, again, creation of drugs is a very big thing. It takes about 12 years. Between 8 and 20 years is the average time to make a new drug. You have to produce that, test it on animals, then test it on critical patients, test it on general patients, test it everywhere in the world, then get a Food and Drug Administration clearance. After that, you can market. Data science and machine learning algorithms simplify and shorten this process. What takes 8 to 20 years can be reduced to 8 to 20 months. This is how the COVID vaccine was done. They collected a lot of data about COVID patients, put it into a deep learning model, and the deep learning model they use is slightly different. They use what is called a graph model. They use the graph model synthesized. They got 10 to the power 4 possibilities for a vaccine. 10 to the power 4 is 10,000. Each one will take 8 months. Rolled off. Then they did some bioinformatic analysis of that. They got 1,000. Then they put it into a machine learning model. It gave 10 most prominent combinations of molecules to generate the vaccine. They put it into a simulator and did classifier. It said 3 of the most stable composition. Each of them was done parallelly in 8 months. That's how you had a COVID vaccine in 1 year. Within 2 years of the first time COVID happened, the vaccine came out. India also did it. What we know is the following. Every company which did vaccine used machine learning in some stage. So today, machine learning for medical data is a compulsory course in all medical colleges and IAC, life sciences, everybody does this. Today and in future, you will have some 14, 15 screens. On that you make your medicine. Everybody does that now today. So second stage is solve problems again in narrow or specific tasks requiring professional intelligence. Those days it was just games, right? Domains of healthcare, fintech, manufacturing, media and others. Scope for solving problems of interest rather than problems of curiosity. We have more there. Significant commercialization, startups and conviction on the role of data. Now it is very clear. Data is the king. Anything you want to do, you must have data for that. This is how IoT solutions based this thing. So you have a lot of sensors and actuators with the old wired and wireless, internet gave. You can have edge IT, edge computing, doing AI with your mobile phone. That's the edge computing. Then of course you can have standard data centers which Google, Amazon all use that. There is plenty of sensors from body, wearables. This is the new technology of future. Already many companies have started in India, wearables. You can collect data about a human patient, healthy human being continuously even from the socks. Well, actually it's a very good opportunity. Now, these are the things the bureaucrats and policymakers, they do some stupid thing, they want to launch somebody into a spacecraft. Do that, that's not an achievement, that is highlighting stupidity. What is your priority? You need 1 million people with jobs. 1 million people of jobs will be this. If you take whatever Tirupur, Madurai, one of the places where textiles is done, Coimbatore, you ask them to put sensors into banyan, panche, all that should have sensors. See, you may have noticed, you must keep one eye and 1 ear out of this college. A lot of interesting things are happening. For example, this year is the first year where in Wimbledon, there are no human beings for doing the line call. whether the ball is out or not. Today you have sensors there. That will tell whether the ball is out or in. So when you can have sensors on the tennis court and on the tennis ball, why don't you have sensors on the body? You can do wonderful things. You can do plenty. The whole gateway is like this. It will not be Internet of Things, it will be Internet of everything. Lot of variables. And today you already have an early watch which gives you continuous ECG. It's only 2,000 rupees the watch. It gives you continuous ECG. And you can do lot of sensors into clothes which monitors, including charging your mobile phone. Even that is available today. So that's it. Lot of gadgets will come. And this is where it is. How to predict somebody is having a heart attack? Collect data from the heart. That's all simple. So you have external sensors. You also have internal sensors like pacemakers and other things which collect continuously. And that's how it is. Collects data, transmits it through a e-gateway, through an internet, through big data analytics, healthcare advice, medical server. It can do emergency web of medical. It can even do emergency ambulance call on your behalf. I know one incident where the ambulance has gone to an house and she says, I didn't call. The ambulance driver says, we know that you need an ambulance, you please come. Yeah. So this is where data becomes, all this is data, decision based on data. So data analysis and data analytics, turning raw data into useful information. That's data analysis. Analytics is getting beyond statistical insight. I have 2 students. I want to recruit them. Data analysis says their average is 50 marks. 2 subjects. Average is 50. How do I select? Both are same. I need only one to select. Now what we do, we select based on alphabet. Government order also is there. Your name, if it's one disadvantage is if you have name with A, like I had. By the time I go to the class, my attendance would have been called. So ideally, best name starts with Z so that you get 15 minutes more for each class to go late. This is it. So I now check. Now I check for variance. There are 2 subjects. One student has scored 50 in both. Average is 50. The other student has scored 100 in one, 0 in the other. His average is also 50. So I go for mean, then I go for variance. I can find data where mean and variance are the same for 2 candidates. More difficult. So I go to higher and higher order statistics. Even there I may fail. I go to different kinds of statistics. All that is what is data analytics today. Okay? Going beyond statistical insight. Useful in predicting the behavior of process. That's machine learning. So this is where it is. This is descriptive. What happened? Why did it happen? Data is available. Predictive analytics. What will happen? Prescriptive analytics. What will happen? Why and when? And how best to handle it. It's done now. Smart grid is using all this. You have now tremendous amount of probabilistic and random tools, applications for doing why the power is fluctuating, whether it will fail, whether the grid will fail, what to do, etc. etc. So these data sets. You learn from data, you use standard computer science, lot of mathematics, but tremendous amount of domain knowledge. What is it? Okay. What is it? Intersection of domain expertise, computer science, maths and statistics. The domain can be business, it can be healthcare, it can be entertainment, whatever. So this is where it is moving now. These things have all been done. Now it is moving systems that learn. Deep learning, AI, cognitive computing, autonomic computing, which is agent based now. And we are here. We have done a lot of narrow AI, we have done machine learning, we have done deep learning, but we are far away from general AI. And with general AI, you can do, hopefully do super AI. When I say general AI, I'm sure many of you here sitting, you are good at home in your cooking, you are good at your department to manage, you are good in the classroom. AI is not like that. AI is a one task you give me, I will do that very well. We are general intelligence, right? So this is the third stage. Solves problem again in narrow or specific tasks beyond what is visualized or prevalent in society. Extend to unfamiliar domains and specific problems of interest. We will come to that. Highly interdisciplinary and technically challenging. It needs multidisciplinary teamwork. Proof of the need to go beyond the CPU. Now why people are depending on GPU and TPU is this. And at the other extreme, when you don't have GPU and TPU or high servers, big data, you can go at the other extreme, look at Edge AI and TNML, which is also gaining acceptance. My feeling is in India, 90% of the AI problems need this solution, 10% need this. What we are doing now is in between the two. That's why we are not solving any interesting problem in our life. We are talking, others are solving, we are not solving. So, this is what needs to be taught. One of the most influential person is Gilbert Strand. Last year, UGC did only one good thing in the last 25 years, that was broadcast his last lecture in MIT. It was 85 years. He said, this is my last class, so that was live broadcast all over the world. We had a very surprising chat message after that. I was watching that myself. One girl from Afghanistan wrote, we have somehow managed to read your book and understand a little. We are so happy to see you in real life for the first time. That's the kind of thing. This is the book. So linear algebra basic, probability and statistics, optimization and deep learning. This is the book which is now available. And the generative AI part also looks like this, the deep learning. It's a nice photo he captured after many times. This is a fisherman in Irrawaddy River in Burma. And then this also, Kannan's book is very interesting to look for. We had earlier books which we were reading before these came. These are the books which we grew up with. And you can see they started very early. The idea of pattern recognition, statistical pattern in 1973, then you had a second edition. And today, one of the most important journal is Siam Journal on Mathematics, which also has a special section series on maths and data science, which has become very interesting. So what next? What is better than data science? What is next going on? So this is data science. Engineering, domain knowledge, statistics and mathematics. Computational science, looking at complex systems, very complex system. For example, COVID. Very difficult to understand COVID. It's like this. I get data like this. I have captured data from all the airports in the world and ports. From this, what can I infer? Today it's very easy to capture data. It's very interesting. This is what computational science does, going beyond machine learning and data science. This is how the Ebola virus spread in the world. Using this model, they were able to do little on the COVID. So data patterns generated by underlying complex dynamic systems is more interesting than the data pattern. I want to know what is really happening which generates such data. Okay. This is it. Plenty of things are going, computational data science, what. So where is it heading? No one knows for sure, but lot of new domains and applications like laptop and smartphone, handheld data science support will be available. Data analytics will be part of many apps that will run on various devices. New computational technologies and data communication interface will enable huge changes in business and lifestyle. Examples will follow, but many more are in the pipeline. Look at this. This is next generation. Quantum machine learning. Quantum machine learning has already solved one problem which no machine learning can solve. So it's already heading that way. And India also has invested heavily. There's a 7,000 crore quantum computing facility starting up, and they have last week announced a special grant for encouraging quantum learning. This is the IBM quantum machine, this is the Google, and you have early computational support for that. And there are plenty of stuff today, lot more, in 20 years. It's a very interesting thing. This you saw, Sandesh? So all of you know Mount Vesuvius, which erupted in Greece, right? It erupted in 79 AD. So a nearby town, there was a library where all the volcano ash came and it started burning. Since more and more ash got deposited, it didn't continuously burn. ಕಲೀಸ್ಲಿ ಹೆಂಗ್ ಮಾಡ್ತಾರೆ ಗೊತ್ತಾ? ಇಜ್ಲು ಮಾಡೋದು, ಮರಾನ ಸುಟ್ಬಿಟ್ಟು ಜಾಸ್ತಿ ಆಕ್ಸಿಜನ್ ಕೊಡದೇ ಇದ್ರೆ ಅದು ಇಜ್ಲಾಗುತ್ತೆ, so that you can use it later and burn it fully. This is what it is. So this is a scroll of paper dated 79 AD, which has got cap turned into coal. It's a manuscript. ಇನ್ನು ಓದಕ್ಕಾಗುತ್ತಾ? ಇದೇ ಇದರ ತುಂಬಾ ಇದೆ ಹರಳೆದು, ಮುಟ್ಟಿದ್ರೆ ಪೌಡರ್ ಆಗೋಗುತ್ತೆ. So it's very interesting. It's an undergraduate student in Germany who did this, and he used, see, it's called Cales Papyrus, was from Herculaneum town, an ancient Roman town on the Bay of Naples at the base of Mount Everest, that is home to the only preserved library from classical antiquity, collection of papyri from which 1,800 mostly unreadable scrolls and fragments have been extracted. Was interred under 60 feet of material deposit by pyroclastic flow, that is post volcano, all that lava that flows, at temperatures greater than 900 degrees Fahrenheit during the same eruption that destroyed Pompeii city. Without enough oxygen to burn, the skulls were baked into charcoal, a blessing because it allowed them to join this. This is really what it is, just like Egyptian this thing. He was able to unwrap sheet by sheet and without touching it. He took a laser controlled laser scan, line by line, depth by depth, and restored these pages. He had trained the machine learning algorithm to detect ink at first level and second level to detect Greek letters, like what you do in LLM and other things. Very interesting work. So fourth stage of this is solve problems again in narrow aspect beyond what is visualized or prevalent in society. Move towards general AI. See if I can read textbook from a charcoal sample, I have really achieved something. Extend to unfamiliar domains and specific problems of interest in problems now understood beyond human capabilities. This no human being can read. Even God cannot read this. Why? If there was God, he wouldn't have made Vesuvius erupt, right? He or she wouldn't have created the problem in the first place. No, it's definitely not. So that interesting problems, okay? Highly interdisciplinary and technically super challenging. You need to know laser technology, you need to know archaeology, you need to know ancient Greek, you need to put all this together and understand that by slowly controlling the intensity of laser line by line, I can get one page at a time opened out. Even today the scroll is like this only. It's in a museum now. But now they are doing for the remaining 1,600 manuscripts. So far we have looked at impressive stuff done with large data. Suppose you had very little data, what would you do? Does it mean you don't solve interesting things? You had no IoT to collect data. You had very little instrumentation to measure or analyze accurately. How did we come to the stage where we are using big data, machine learning, data science now? Let us see how these things were done. Look at this, one of the earliest well-documented case. Whether the earth is flat or round, this is really what happened about 2200 years back. When Earthosthenes measured the circumference of the earth using two data points. One data point in Aswan Dam, what is today Aswan Dam, the other data point at Alexandria. But he had perfected all other things. It must be on day of summer solstice. On summer solstice day, sun at 12 o'clock noon will be on Tropic of Cancer. And Cyan is on Tropic of Cancer. Alexandria, which is 50 miles to the north, will not be on Tropic of Cancer. Therefore, at the same time, there will be a shadow cast on a stick kept. Using heights and distance problem, he measured the circumference of Earth. This is how he measured. So this is in Cyan, that's in Alexandria. Measured how much shadow it cast at the ship. So all the idea of geography, celestial mechanics, planets, seasons, location of the sun, timing, getting, all this was done with two data points to get it. That's how he did it, okay? So he had to know physics, math, geography, astronomy, humans, social sciences, management, philosophy, scientific temper, all that to do this. So if you have less data, you need more intelligence and sense. Today's generation, no sense, no intelligence. That's why you need lot of data. Next problem is even more interesting. There is a problem of 6 supposedly planets. Mercury, Earth, Mars, Jupiter, and one major moon called Ceres. So that orbit of that data, very interesting that that Ceres went, we are here on Earth, the Ceres went behind Sun. And so they thought it is lost. They said it is lost, we are not able to observe. The challenge is, will it come back? Or some planet has devoured it. So this was a challenge in Europe. Gauss took it up, many people took it up. Gauss gave the best solution. He not only predicted correctly when it will appear behind the sun after 3.5 months, it also gave the location in the sky where you can spot it. When people spotted it with a telescope, they put a death sentence on Gauss because they told you are a black magician. Sorcery was put to death those days in Europe. And Gauss took 8 years to explain. He said, I know it works. I know the answer, so I have given you the answer. You have verified the answer is correct. I will give you the method after some time. So he took 8 years to publish what is called today the method of least squares, which all of us use for regression model, curve fitting, everything. This is Gauss's, modern version of Gauss's. And he took 6 observations. Okay. And they have used this, particularly in World War II. This is Wiener, this is Kolmogorov, 2 of the greatest scientists of 20th century who use statistics and other things. The problem of anti-aircraft gun. The method of least square simply says, I want to destroy this plane, I estimate the trajectory, and I will fire ahead of it so that by the time the projectile goes there, the plane can come and hit. So plane gets, this is how anti-aircraft gun, submarine, today your cruise missiles, all your BrahMos missiles also work on this. What is interesting is, he said, this plane can come here and fly like this. It can go like this. So what he said was, I will give a target and a circle of error around it. You fire anywhere. When will it succeed? If the radius of the circle is small. That's how least square error has to be minimized. This is what Gauss did. And that's what your Iron Dome does in Israel, what Pakistan is tried using on us. All this is just this. Very interesting with data, what you can do. See, this is a use of actual statistics which goes to data analytics shortly. This is a situation in World War II where the plane has come back with a wing missing. You can see so much of bullet holes. See, every time those days you haven't experienced, you haven't faced. But when people go to war, they bid them goodbye because they don't know whether they'll come back alive by evening. Right? So this is typically how it was. And the question is, I have data for all this, data here, data for all this. I want to make the plane more safe, so that is where. I want to put more steel plates. Where should I put more steel plates? How and where to add extra armor? If I put more steel plates, it gives more weight to the plane, therefore less mileage. And it's very heavy, you can't maneuver easily. You will be surprised what happened to the first atom bomb. When the first atom bomb was dropped on Hiroshima, not Hiroshima, Nagasaki, I think, first one.
Yes.
You know the condition? They said you drop the bomb, fly south towards China. Then you take a parachute and jump. Let the plane go and fall in any sea, because to carry the atom bomb and go all the way and bomb Japan, there was no fuel to come back. So when you make the plane very heavy, you don't come back. That was the condition for the pilots. They said, you will not be clear, you may not come back. Because you have no fuel to come back. All that fuel is taken up by the atom bomb, which is very heavy. So we will have enough fuel for you to drop the bomb, come to China coast, jump off. We will rescue you if you are alive. Interesting. Yeah. So less weight is risky with loss of aircraft and pilot. More weight, less mileage and less maneuverability. So this is a minimax problem. What we do in machine learning today is this. I want to minimize something and maximize something else, right? And it's very interesting. They got data. He said, they asked somebody, statistics, interesting fellow. He said, get me data of all the planes that you have. So they collected data and said, this is how the data looks. So a lot of scientists came and said, okay, this is where all this, so you put plate here, steel plate here, steel plate here, here and here. That's what everybody said. But one interesting fellow, he said, put more steel plate here, 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 here. Don't put here. Why? This thinking is important for future, because the problem with all of us, you as teachers and students who come to you, you yourself have stopped thinking, so you don't make them think. Thinking has become the most damaging thing of this generation, closely followed by reading and writing. Very bad reading, very bad writing. Writing is gone. So this fellow analyzed and said, how did you get this data? You got this data because the plane came back to you. The plane came back to you and you have this data. What about the planes that did not come back? They were all shot here. That is why they didn't come back. So he said, put more armor there. This is how what is called the statistical analysis of survivorship bias. So this is Wald who did that. See, experts thought they should reinforce where the planes were most hit. Wald thought the opposite. He said, all the places where they are not hit, we put this up. At least thousands of pilots' lives were saved by him, by a statistician who analyzed data. They didn't have machine learning. Gauss didn't have machine learning. Ertasane didn't even have data. He had one stick, that's all. We have GPU, TPU, Python programming, that's why we don't do anything useful. So as a tribute, I think you should not miss doing machine learning and data science. You should not miss this. He was born on 10 September in Huvin Hadati. This Professor S.R.S. Rao, C.R. Rao, world's greatest statistician and mathematician of all times, and really greatest of all times of data scientist. You can't beat him. Okay? He died aged 102. I met him. He had come to Indian Institute of Science. I met him when he just was migrating to US. He got the Bharat Ratna equivalent in US but didn't get here. Whereas this idiot Sachin Tendulkar got it. So you see what our priorities are. People who make us not learn, people who make us waste our time get Bharat Ratna. People who make us learn, no. So what is interesting about him is this. This is C.R. Rao with Wiener. This is C.R. Rao with Kolmogorov. Two of the most difficult people on earth to get. He made them come to India. Particularly Kolmogorov, not even allowed to go out of. He never went to America. Kolmogorov never went to America. So food is ready?
Yes, sir.
Yeah. 5 minutes. Kolmogorov went to Russian External Affairs Ministry and told, I have received a thesis from India, which is one of the world's best theses. We have never seen that kind of work. I want to go and examine the student personally. Can you permit me to travel out of Russia? That's how he came. And that student was S.R.S. Vardhan, who became the current institute director. ಆ ಥರದವರೆಲ್ಲ ಇದ್ರು ಇಲ್ಲಿ ಯಾರು ಗೂಬೆಗಳೆಲ್ಲ ವೈಸ್ ಚಾನ್ಸಲರ್ ಆಗಿ ಎಲ್ಲರೂ ಹಾಳು ಮಾಡ್ತಾರೆ. ಅವ್ರನ್ನ ನಂಬ್ಕೊಂಡು ನೀವು ಹಾಳಾಗ್ತಾರೆ, ನಿಮ್ಮನ್ನು ನಂಬ್ಕೊಂಡು ನಿಮ್ಮ ಸ್ಟೂಡೆಂಟ್ಸ್ ಹಾಳಾಗ್ತಾರೆ. ಅಷ್ಟೇ ಆಗಿರೋದು. ಸೊ ದಿಸ್ is the book which changed the world. This is the book which made statistics the most important subject in the world, even in America. Okay, this is the second edition. What is interesting is he wrote a book on machine learning when he was 101 years old. This is the book. Statistical learning using machine learning is a wrong term. Statistical learning is the correct terminology. He wrote that when he was 101 years and he used Python and R programming there. He learned R programming when he was 95 years old. Yeah, so what to learn to and from? To do AI/ML, data science, analytical, statistical, numerical and algorithmic competencies are non-negotiable. Interdisciplinary, multidisciplinary outlook and familiarity is a must. Domains relating to agriculture governance are important to India and potential success, which is not addressed there. For defense and security are niche and heavy interest domain. Cyber security in all these are very important. And from AI/ML, Python programming is not enough. If you can do some programming on GPU, TPU, which is called the CUDA programming, that's okay. But Edge AI and TinyML have significant potential, more so in India. To AI or not to AI is very essential to be resolved, saying which problem deserves machine learning solution, which doesn't. Train on well-defined problems but solve difficult problems. Attempt Indian knowledge system domain for analysis using AI/ML, which can be done. So I am done with my presentation. Any comments, questions? I will take one or two, but during lunchtime we can share more time.
So when you say students that they have to be AI ready or they have to know AI/ML in future to get employed, what do you mean by AI? Like is it the tools or the algorithms or the domain specific one?
First, most important is, can they understand a domain which is either taught or not taught? Which mostly will not be taught. That domain they have to understand. So suppose it's healthcare, they can focus only on one. It can be cardiac or it can be neural, it can be orthopedic, everything. One domain. I am not saying that they become doctors, but they must know basic terminology, what it means, all that. They must understand how the body works. Or if they take finance, they must know what is the stock market, how these things happen. All that is not taught.
Agriculture.
The one advantage of agriculture is many of them have their roots in that, so it's very easy for them to address that. Without domain knowledge, skill has no use. Domain knowledge must, ideally you must have electives in domains, which will be advantageous to your students compared to other colleges.
And then see how to solve the problems in those
See, they must understand the domain, then they can identify problems. Suppose I go and say one of the most difficult problem is sepsis. Most students, teachers also don't even know the word, they don't even know what it is. So, lacking that, they'll say, okay, you become good in Python. That will not help. Getting people to code is very easy. Getting people to think, impossible. That's where the future is. The other extreme is, can I do tiny ML? Can I do machine learning on embedded system? That's a very big future, which is where I am focusing. I am not focusing on these things. I am focusing on tiny ML and solutions. Why all this cloud give and all that? You must have a small hardware board which goes into a box with a battery right near the Tangin Marad Pati hatra. That should be able to solve the problem of coconut. I don't need Amazon to give me all the infrastructure. That's one extreme. The other extreme is this. Without domain it's difficult. Domain knowledge, yaru select agala domain knowledge. That's why, particularly in Bangalore, unfortunately, I share a course on data science in RB. We changed the whole scheme. We said completely project-based semester. 90 students did project for one semester. We didn't teach. We taught only 6 hours in the class. 3 hours initially, how to do, what to do, etc. Made to batches, sent them to every. Somebody went to blood bank, somebody went to Kengari bus stand, somebody went to city market. I don't just go sit down there, talk to customers, watch, observe, record, come and tell what you have seen. Find out what you have understood about the problem, then we can look at solutions.
So how would like teaching or education system in future be using AI?
See, education system in future will see AI is now doing in education particularly customized tutoring. See, I learn in a very peculiar way. Some are fast, some are slow, some learn with examples, some with explanation, all that. So AI-based tutoring systems have come now. They will teach a particular student the way he or she wants to learn that particular subject. That will happen. And then most of learning in future is self-learning. Classroom learning will be very little. You can, that's why till 4th semester, 3rd and 4th, rigorous analytics and basics should be built. After that, it will all be project-based, and now at least 7th and 8th semester, 8th semester nobody is there. 7th semester, Atakuntu Lekkakilla. Right? So you have 1st and 2nd semester, they don't know what they are doing. So you have 2 years time, you have to do something. 1 year basics. Basics are very important. Basics are very important. So they can start orienting at least to 2 domains from 4th semester end. See, the best learning happens in vacation, not in class semester time. Test go, assignments, blue book correction, bari ale agoytu. Vacation is where they can use very well. See, in 2 months vacation, they go and sit in a farm and rough it up. They will learn reasonably well. Or they go, they have parents are connected with the nursing home, they can spend time in the nursing home and collect data, analyze patients, understand, basically understand. Yeah.
Any more questions? I immensely thank Dr. Ashok Rao sir for this session. and he has given us the hint of what might happen in the future. And we as teachers, we have a very responsible role to play to make our students AI ready so that they survive in their in the future in terms of work or in again as responsible humans. So it is very important for us to focus on data science or as Sir tells on building up their domain knowledge. So motivating them to take up tasks or do their projects, because today we see most of the students do deep learning projects. So they just give the data set which they download from the net, which is already available, and they show us the output. So even we are not in a position to gauge whether the solution that they are getting is right or not, or whether the data that they have given is valid or not. So it's our responsibility as guides to see that they collect valid data, the real world data. So, and then see that they actually apply, as I again tells, thinking is very much important from our end as well as from making students think as well. So with this, I thank Sir for the various, where AI is applied in the various fields or in future. Again, thank you so much.
That boy who solved that archaeology problem, he didn't go for anything. He just out of curiosity as a challenge. It's a $1 lakh challenge task he took. After he finished that, Harvard, MIT, Stanford, everybody called him and said, please come and join on a fellowship. So once you solve interesting problem, the world will come to you. If you don't solve, or if you don't even attempt, you will have to go chasing the world for 2 square meals a day. That is what is happening to our students. The student, today's generation is highly energetic, aware, but they are immature. So how you handle them and liberate them, that's where the thing comes. Okay, thank you.
We shall break for lunch now and again
2 o'clock.
gather, 1:45, around 1:45.
Yeah, 145, 150 quickly. So
Yeah,
we keep time.
We'll have hands-on session in the lab in the afternoon today.
Come.